Hey everyone, sorry we didn't get an episode out to you guys last month in August, but we'll make it up to you. On behalf of everyone on the Visual C++ team, we hope you enjoyed your Labor Day weekend, and today we are excited to celebrate the release of Visual Studio 2013 Update 4 CTP1. In today's episode, we'll be looking in particular at one of the improvements that we've made that we are super excited for you guys to get your hands on, so let's get right to the interview. Hi everyone, welcome to our latest episode of Channel 9's GoingNative. My name is Gabriel Ha, in front of the camera this time, and I guess you'll find out why. But before we get into today's episode, just like to introduce everyone in the room. So I'm Gabriel, I am a program manager on the Visual C++ team.
I'm Alek, I'm a developer on the Visual C++ team.
Hi, I'm Vaijanath, I'm a member of Experience and Insights team.
So the problem that the three of us, as well as one other dev, Vitas, attempted to solve is, if you guys have ever noticed during the course of your coding experience, that every now and then when you try to run, like for example, a go-to definition or find all references on a symbol, Visual Studio kind of locks up on you, and you see this little bar that goes across and says, please wait while IntelliSense and browsing are updated, that sort of thing. And this is kind of an annoying experience, and some of you might not even know why that comes up in the first place and why it seems to happen very randomly. So Alek, would you mind explaining what exactly is happening when that happens?
So what happens is every hour Visual Studio rescans all the external dependencies that are parts of your project to make sure that those files are still up to date. It turns out that it's too expensive to install a directory watch on every single file in the external dependencies. Therefore, we opted to have the solution where every hour we just check the modification. However, in some of the large world solutions that we receive from our partners, this operation was taking an exorbitant amount of time. For example, in one particular solution, this took over 5 minutes every hour. So during those 5 minutes, the browsing operations such as go to definition or find all references were unavailable, and what users would see was the status bar or a dialog box that said, please wait while browsing or IntelliSense information is being updated.
VJ did a lot of investigation work to find out what exactly we needed to do and some solutions for how we could go about fixing this. So VJ, do you mind talking about that for a bit?
I took the solution that one of our partners gave, which was a really large solution. It was not very big in terms of the number of projects in the solution, but it had a set of makefile projects which were not set up for IntelliSense information, and they were structured for cross-platform development and hence not very truly optimized for Visual Studio. Here the problem appeared magnified, and we could easily pinpoint what exactly was the root cause of the problem. What we did was we have several set of tools that we use internally to profile performance information from operations like solution load, all the browsing operations, and we did periodic benchmarking on various hardware, and we found that the essential bottleneck was this sparse solution that happens periodically has to be optimized better, because we cannot have our users blocked for 20% of their time just because we are doing a periodic check. We felt that most of our customers won't have to update their solution so frequently because they'll be working in an environment where they would not have modified their files, or if they have edited their files in Visual Studio, which we already will have known about the new state. Only when files are edited outside Visual Studio, we might have to do a scan. We did periodic scan every 60 minutes. We wanted to optimize on this, and Oleg did the major work on that.
So there are three distinct situations in which you guys are going to see massive improvements in the amount of time that you need to wait for Visual Studio to do its thing in the background, which unfortunately blocks you right now. When you first load up your solution, it will be scanned to build up the database so that operations like go to definition and final references will work. The second situation in which this happens is the automatic rescan, which both Avieg and VJ have alluded to occurs every hour. And the third situation is if you force a rescan on your solution. Now, there aren't very many circumstances in which you would want to do this. If you have questions on when you might want to do that, feel free to ask us in the comments below. But take our word for it that there's a very rare chance you'll actually ever need to rescan your solution. So to show you the results of what we did, let's go right into the demo, and we'll let you see these massive improvements for yourself.
So when the solution first loads, there's an amount of time that it takes to scan the solution, and then periodically, every hour, your solution would rescan. And during this interval, you would be blocked from doing any kind of browsing operation like go to definition. Now what we've done is we've attached this instance of Visual Studio to another instance of Visual Studio, and we're currently debugging with that other instance. And so we've set 2 breakpoints. The first breakpoint occurs before the solution rescan, and basically what we're going to do is we're going to release the breakpoint, start a timer, and then see how long it takes to hit the next breakpoint, which is positioned after the automatic rescan is done. And after we get the settings set up here, we will show you our world-class automatic rescan solution timing device. It is called Internet Stopwatch. So let's go ahead and do this thing. Alright, so timer's going. We're going to speed things up here a bit just so you can see how long this takes. And oh, it looks like the timer's slowing down. There it is. So 2 minutes, 19 seconds, or a little bit less than that as we started the timer a little after we released the breakpoint. So let's see how things are after the improvements. There goes the breakpoint, and whoa, did you see that? You almost didn't, because it happened that fast. So essentially, with the new rescan algorithm, we've got this under a second. Alright, so let's take a look at how long it would take if you actually force the solution to rescan. So this is not the automatic rescan. This is essentially building up the database again. So our timer is going, looks like we're going past 2 minutes again. And 2 minutes, 27 seconds is when we finally hit that post breakpoint. And now let's see what it's like after we've made the changes. You guys can see the familiar and probably annoying green bar, please wait while IntelliSense and browsing information are updated message. And after 1 minute and 21 seconds, which is long but not nearly as long as over 2 minutes, the solution finishes its rescan. So all you have to do is update your Visual Studio to the newest update, and you will see these improvements, particularly for large solutions.
So here, we're going to show you guys some of the changes that we made to our code so that you guys could experience these improvements.
And I actually would like to focus on the process of investigation, what changes we needed to make in order to make the scanning operation faster. So because the operation is taking a long time, I have the luxury of being able to attach and profile what Visual Studio is doing. And since I love Visual Studio, I will profile using Visual Studio. So I'm going to go into the Analyze tab and attach to Visual Studio the one that's currently doing the very lengthy operation. And you can see that the profiler is currently going. It's collecting the information. The rescan, like VJ mentioned, takes over a few minutes. So I will just let this run for a while and collect quite a few samples before stopping the profile and getting some actionable data from it. So now we have collected a sufficient amount of data. Let's see what the profile information will tell us. The profile report is being generated, and now we see that most of the work is spent in the function that is grabbing the search path. And the search path is just, we use the project system to ask for the paths where the include files might be, and we query the paths and split them up because they're semicolon separated, and actually search those directories for every include file. Now you might see some interesting things here. The most interesting function here is get directory entry. So the way we do directories is we use a Bloom filter, which is a probabilistic data structure, to store all the files in every directory so that we don't have to query them on disk for every single file, for every single directory. The Bloom filter is a very useful data structure for this. You need a few hash functions to hash the name of your file, and if the bits match up, then the file might be in the directory, but if they don't, then it's definitely not going to be in the directory. We retrieve the directory entry by using the find function of the standard templates library map algorithm. In fact, this directory cache is a map, and from the profile over here, you see that 10% of the entire time is spent in operator and less than, And then something you might notice later is that 6.3% is spent in basic string. I'm just alluding to it now, and I'll spend more time on this later. So let's actually go and see what this directory cache variable is. Directory cache is basically a map from a string to a directory info which contains the Bloom filter I mentioned earlier. And one thing that we can optimize is the searching in the map. So this commented out code is the code that we added. Basically, the trick is that lookups in the map use the normal strings less than function, but that is not very well suited for directories because the very first part of each directory is very likely going to be c:\users\, etc. And if we can short circuit that comparison somehow, then the find is going to be a lot faster. So in this directory less comparison, we're using a reverse lexicographic comparison where we're first checking the lengths of the directories and then we're iterating the directory characters backwards because that's going to be a lot faster than just comparing the strings. So the third parameter to the map is going to be directory less, and that's going to save quite a bit of time for the whole operation. The second change was something I mentioned earlier, basic string. Actually, this is not apparent if you just look at the code, but what happens is that the parameter to the getDirectoryEntry function is just a const wchart star. And the find algorithm implicitly constructs a string from this string, and this conversion actually accounts for 6.3%. Well, as it turns out, at an earlier place in the program, we already had a std string, so there was no need to cast that to wchart and then construct a new string. So what we did here was we simply replaced this parameter with a w string to avoid that copying altogether. So these two optimizations are going to make this operation a lot faster. And the third optimization we did, which actually saved quite a bit of time, was we changed the algorithm even more. So right now the directory cache contains a map of all the directories that are on disk, and they contain the Bloom filters for all the files in the directory. However, if you look at this line right now, if the directory doesn't exist, we exit early and we don't store the failure information in the cache. As it turns out, in this particular project, there were a lot of paths which were actually not present. They must have been entered by accident into the extra additional include directories and were not cleaned up properly. So what we did was we changed this line to, instead of returning early, store a new directory entry with a special Bloom filter that indicated that there were no files in the directory. And this find first file W call was avoided for all those directories. So after we did all those and additional optimizations, we're able to save quite a bit of time from the rescanning operation.
So hopefully seeing this example will give you guys an idea of the usefulness of the profiler, and hopefully encourage you guys, if you have any sort of similar situations that you need to optimize, hopefully you can take away some of these tips that Oleg just gave us and use them in your own projects. So we hope you guys are as excited as we are for you to get your hands on these improvements. But even with the improvements, as you can see from the demo, and because we've only demoed it on a particular code base, you might still run into some situations in which you'll have the sliding thing that blocks you from performing your browsing operations. So we've looked into other solutions to improve this workflow.
Population of database is inherently a slow operation, and we wanted to not block users while doing this operation. So going forward, what we will do is, if the initial scan or browsing population is happening, and if you want to do go to definition, find all references, all the previous blocking operations, from now on we will not block you, and we'll try to find the data. If we already have passed this section, then if the data is already present, then we'll present it to you. Or else we can prompt a message box saying that the browsing information is still being updated. You can wait till this rescan is completed.
So while you guys won't find these updates yet in the VS 2013 Update 4 CDP1 that's released today, you guys can look forward to these updates in a later release. So here we're going to preview one of the changes you're going to see in a future update for Visual Studio 2013.
I would like to demonstrate an example of the feature behavior in Visual Studio after we unblock the browsing operations before the solution is ready. So one example is this. If you make a modification to the source file is not going to be immediately up to date. So if you invoke a go-to-definition operation, it might take a second or two for it to succeed, even though the previous change probably didn't change the eventual outcome of the operation. So here's the behavior that you will be able to experience in a future update. Make an edit and go to definition immediately. You notice that there is a yellow bar on top of the current file that says solution has not finished parsing, browsing results may be inaccurate. And they will be inaccurate if you do edit the actual result of the go to definition, because we won't have that up to date. But in most cases, it'll be fine and the result will be just what you expect. And this bar will go away if you close it or if you invoke a successful go to definition operation.
So does this also work if you are changing function name? Will it still go to def on that? If you make a change here, you would want to be able to edit the other part, right? But you can't because...
It might work, might not work. It depends on how fast you do it. If you change the name and quickly go to def, then it'll still work for the next 2 seconds.
So that's it for our episode today. Go to the links in the description below and try it out for yourselves. Let us know in the comments what you think. And this has been both informative and a big help to you guys. So Alieg, Vijay, thank you so much for joining me. And it's been a pleasure to work with you guys.
Thanks for watching.
Bye-bye.
That's our show for today. As the other version of me in the interview said, hope you found today's session both informative and useful. Be sure to check out Visual Studio 2013 Update 4 CDP1 for yourselves, and be sure to leave us any positive or constructive feedback in the comments below, including any episode requests that you guys might have. We'll do our best to make it happen. Thanks for watching, and see you guys later this month.